Hello everyone. Today we will introduce the second law of trigonometry, cosine law. Before we do that, let's recap one more time what sine law states and what are the cases that we can use sine law to solve a triangle. So sine law states that the ratio of the sine of the angle with the length of the side opposite that angle is the same. Okay, and we can write that in like in the first case here with sine with the angle in the numerator and the length of the side in the denominator, or we can write the length of the side in the numerator and the trigonometric ratio of the angle or sine of the angle in the denominator. And if you recall, we said that if we are solving, to make it easier when we isolate for the variable here when we solve, if we're solving for angle, it is easier to use the first expression here. If we're solving for side, it is easier to use the second one, and we're always going to use only two of them depending on what side what side we're solving for and what is given. So we're going to choose two of these ratios, and we're going to have the length of the side in the numerator, and then you're going to multiply. You can use, let's say we're solving for side A, you're going to multiply both sides with sine of angle A, and to the left you're going to have the length of the side or the variable on its own, and here you're going to have B multiplied by sine of A over sine of B. Okay. If you're solving for the angle, let's say you're solving for angle A, then you are going to, it will be wise to have a sine of A in the numerator, and you multiply both sides by A to eliminate the denominator. Then you're going to have sine of B multiplied by length of A over the length of side B. Regardless, both of them are accurate if you choose either of them to solve the triangle. Now, when do we use cosine law? Cosine law is used when you have two sides and one angle that is opposite the triangle. So if you recall, we said if you can create this kind of opposite pair and then another side or another angle, you can use sine law. Another condition which satisfies the one that we just said here, but if you have two angles in any side, okay, two angles in any side, or two sides and one angle that is opposite the angle, this is crucial here, that the angle that is given when you have two sides must be opposite of one of the sides that is given. And as we introduce cosine law, you will understand why that is important. All right. At the end of the lesson, please come back to the I can statements and check that you can answer all these questions. You are able to answer all the problems that we are going to talk about. All right, so let's go ahead and introduce the cosine law. Okay. Cosine law states that, so first let's talk about the sides, but this can be a general formula for cosine law. It states that the square of the length of a side equals the sum of the square of the other two sides minus double the product of the other two sides multiplied by cosine of the angle that is opposite the side that we're solving. Okay. That is the pattern that you will notice here. So we have a squared equals b squared, the other two sides. We have this b squared, we're adding them together. We're adding the other two sides squared. Okay? And then we are going to subtract double the product of these two sides multiplied by the cosine of the angle that is opposite the sides that we're solving for. It's very important that you understand this pattern, because regardless what side is given to you, you can easily put this formula together. Okay, one more time. This side squared, one of the sides squared, doesn't matter which one, I'm not even going to label them. One of the sides squared equals the sum of the other two sides squared minus here, the double the product of these two sides multiplied by the cosine of the angle that is opposite the side that we're solving for. Okay, so if you have side A here, over here is going to be cosine of angle A. And if you rewrite the formula for the other two sides, as you notice here, you're solving for side B, here you're going to have cosine of angle B. You're solving for side C, here you're going to have cosine of angle C. And then all sides are squared in the formula on the first half. And then you're going to add the square of the other two sides that are given to you. From that, you're going to subtract double the product of those two sides multiplied by the cosine of the angle opposite. Okay, spend some time here to understand this formula. I know you will have it in front of you as you solve your problems, solve the triangles, but it's important to understand the pattern in the formula because it will be that much easier for you to solve it. All right, let's continue on the next formula for when we solve for angles. So if we isolate from the formula that we were first introduced for the sides, if we try to isolate the cosine of the angle, we're going to get the formula here. Cosine of angle A equals B squared plus C squared minus A squared over 2BC. Now let's see the pattern. It's exactly the same pattern that we talked about it before, but here now we're talking about the angle. So if we're solving for angle A, what we're going to do, as you see in the numerator, we have the sum of the square of the two sides that contain the angle A. Okay, the two sides that are the arms of the angle that we're solving for, minus the square of the side that is opposite that angle. So this what is going to be on the numerator. Make sure that you subtract the square of the length of the side that is opposite the angle that we're solving for. And then in the denominator, you're going to have double the product of the two sides that contain the angle that we're solving for. Okay, angle A in this case. And once you understand this pattern, please come back to this before you check the other two formulas to understand the pattern that is going on with cosine law when we solve for angles. Okay, once you have that understood, solving triangles using cosine law will be pretty straightforward. Now let's check the cases when we can use cosine law. Again, the formula that you need to view is only this. When you have cosine, you can plot all the variables and you're going to isolate the cosine of the angle A, and you're going to solve using the inverse for the angle. When can we use cosine law? This is very important here. Highlight that into your notes. The cases when we can solve the triangle using cosine law. The one case is when all three sides are given to you, and evidently we're going to solve for one of the angles or all the angles. Okay, if sides are given to you, you know you're going to use cosine law. Another case is, so this is considered as side. Okay, side. This is one of the cases. Now on the second part here, we have two sides and an angle contained angle. So that is side, angle, side in this order. Doesn't matter which two sides. The angle that is in between those two sides must be given in order for us to use the cosine law. Okay, we're going to view a few examples here. What does that mean, especially to clarify a little bit what the contained angle means when we use the cosine law. Okay, so if you have the triangle ABC and we label the sides as we have mentioned, or using the same letters as the vertexes but lowercase. So opposite angle B is side B, opposite angle A is side A, and opposite angle C is side C, all of them lowercase. Now if you have given to you side C and side A, so side C and side A is given to you, in order to use cosine law, the angle in between those two sides, it's called the angle contained by those two sides, must be given. Okay, so we're talking about angle B. If C and B is given, the length of sides C and B is given, then we are talking the angle contained by those two sides is angle A. If B and A is given, as we saw it in the first slide, then angle C is the one that we're talking about. So again, the pattern here, if A and B is given, and again, we're assuming that the triangle is labeled ABC. So if the two sides are given, the third letter should be the angle contained by these two sides. I hope that made sense. In general, if we do not label the triangle ABC, then if two sides are given, then you're going to look if the angle that is given is the one with the third letter or the angle contained in between them. Let's not complicate it. Okay, so that's what the contained angle means. All right. Now let's go ahead to the next slide where we can solve one example. Okay, triangle MNP is given, and we are asked to solve for the length of the side N. Okay, so once you have the length here, you don't have to go. That's why it's important for you to understand the formula. So you don't have to go back and label the sides. So here 13 centimeters is side M, okay, and 25 centimeters is side P. And we're asked to solve for side N. So write in the formula, going from the general formula that we know with ABC, we're going to have, we're solving for N. N squared equals P squared plus M squared minus double the product of P and M multiplied by cosine of the angle N. Okay, so we have here substituting the values. N squared equals 13 squared plus 25 squared minus 2 multiplying. So whatever values you have here, you're going to multiply them without the square and multiplying by the cosine of the given angle. I will suggest that when you put this value in your calculator, first of all, you will know by now if your calculator works forwards or backwards. I will suggest that you put these two values first, and then these two terms together, and then whatever outcome you have on the second term, round it to whatever you see it reasonable, normally to the first or second decimal, and then subtract them. And then don't forget here now to take the square root of the value that you have, because the formula is giving you N squared. Is very similar if you see at the Pythagorean theorem, okay? Without the second part here, without the subtraction. So remember that, because we have practiced way more the Pythagorean theorem when you isolate the value of N. Okay, so once you understand the formula and plot the values to the right places, is pretty straightforward using cosine law to solve oblique triangles. Okay, on the second example now, we are given three sides. Okay, and we're asked to solve for an angle. Now let's make the connections from the word problem to the diagram, because it's very important. Sometimes you will not be given the diagram and you're gonna have to draw the diagram in your own. So 3 towns are connected by 2 roads, BR and RH. So there you go, you have the 3 letters for the triangles that you're going to use, B, R, and H. Okay, here it says as shown, but if you were asked to draw the diagram. A new road is planned that will directly connect Brookside and High Cliff, so B and H here, which are 16.5 kilometers apart. B and H, 16.5 kilometers apart. Find the angle to the nearest degree between the new road and the existing road that is formed from the new road and the existing road. All right, so the angle that we're talking about is angle H. I grab the, okay, is the angle H here. Okay, this is the existing road, this is the new road. All right, so we're solving for angles, so we're going to use the formula for the angle. To adapt the formula to the given triangle with the letters B, H, and R, we're going to label this triangle based on those letters. So opposite angle H is side H. Okay, opposite angle R is side R, and opposite angle B is side B. Now we're going to go back to the formula. We're going to have cosine of H equals the square of the sum of the two sides, so B squared plus R squared, minus the square of the side opposite, minus H squared, divided by double the product of the sides that contain the angle. Okay, once you have that formula settled, you are going to substitute the values that are given to you, all three sides. Please make sure that to check the formula that you're subtracting the side that is opposite the angle that is given to you. Okay, and on the denominator you have both sides that contain the angle. Okay, make sure when you plot the values you are doing that correctly. Then put that into your calculator. You have cosine of angle H equal to this ratio. Every time we use when we solve for angle, we're going to use the inverse of the function, cosine in this case. Put that into your calculator, round your answer to the nearest degree as required. Okay, pretty straightforward. Don't overthink it. The only thing that I need you to pay close attention to is when you plot the given values into the formula. Okay, that's it. In this next example, we have an air traffic controller at point T that is tracking two airplanes, U and V. Okay, they are flying at the same altitude. How far apart are the planes? So the planes are in the same, if we can visualize it, they're in the same horizontal space. So now we have to figure out what is the distance between them. What we're going to do, and based on the diagram that we have, the angle from north to the angle to the airplane V, so from the controller to the airplane U, let's start with U first, is 23 degrees. And from north again to with the line that connects the controller to the airplane V is 75 degrees, which leaves us with angle UTV with the measure of 75 minus 52 degrees. So we can write that here as 52 degrees. So that angle is 52 degrees here. All right, now we can label the triangle. So here we have T, here we're going to have letter V, and over here we're going to have letter U, all of them lowercase, right? And we have to solve for T. So we can have T squared equals V squared plus U squared minus double VU multiplied by cosine of angle T. Okay, and now we plot the values. T squared equals V is 10 miles, so 10 squared plus 15 squared minus 2 multiplying 10 multiplying 15 multiplying cosine of 52 degrees. Okay, and we said that we're going to do this separately here. So 10 squared plus 15 squared is 325. Then we put the rest in our calculator and round it. Let's round that to the first decimal point, 184.3. Okay, subtract that. We have t squared equals 140.3. All right, now we need just t. So we're going to take the square root of both sides here. Don't forget that. So t equals 11, rounded to the first decimal point, 11.8 miles. There you go, the therefore statement. The airplanes are 11.8 miles away from each other. Okay, so it's pretty straightforward using both laws. The only challenge, if we're going to call it a challenge, is deciding which one of them we're going to use when you have the information. So it's very crucial that you go back and you check, or you can write, compare and contrast when you use sine law. These are the two cases when we use sine law, and when you use cosine law. These are the two cases when we use cosine law. Okay, that is very important for you to understand. We're going to work the next lesson with more problems to illustrate both of them. For today, please go over this video and the slide, write your notes, and for additional practice, you can do these problems from the textbook. Okay? All right, that's it for today. I will talk to you next time. Bye for now.